We're going to go ahead and get started today. Thanks everybody for joining our green building break. This is a session that we kind of implemented, I guess, starting last year. On Fridays, we do these either webinars on green building hot topics, or sometimes we intersperse those with in-person green building tours that are just a little less formal than some of our evening programs. So welcome everybody and thanks for being here. Um, uh, I guess we're just going to jump right into the topic today, which is prefabricated straw bale panel construction right here in Missouri. I um, I got a couple, I guess it was last year sometime, I got an email from our presenter, Adrian, and it was a promotional email about, they were doing a demo on, prefab straw bale panel construction. And I was like, oh man, that's cool. And that's in Missouri. And we should really be highlighting it. So here we are doing that today. And, I'm happy to have Adrian Stolwick here from Monarch Architecture. I first met Adrian many years ago when we launched a Mid Missouri branch in Columbia, and she was involved with that branch, and she's been busy since then. So her firm is located in Columbia and focuses primarily on custom residential and high performance design. And she's been a straw bale construction enthusiast for a long time, has worked on projects in Missouri, New Mexico, and Utah, and in her very own backyard. So I'm going to turn it over to Adrienne. She'll share her screen and get us started.
Yeah, awesome. Thank you, Emily. And I really appreciate the opportunity to talk with you guys about this today. I shall share my screen. Can you guys see that okay?
Good.
Yes. Okay, I
Yeah.
see a thumbs up. Excellent. Cool. Yeah, so as Emily said, I'm located in Columbia, Missouri. And about 5 years ago, I started Monarch Architecture, doing mostly residential, but I have a background. I worked for 10 or 12 years in commercial architecture. Um, yeah, but this other logo here is for a company called Building Integrity, which I co-own with four other owners, that is fabricating prefab straw bale panels in Colombia. So I want to tell you about that company, but really as part of a whole broader history of straw bale construction in the United States and in the world, and kind of where I think it could be going with this prefabricated technique. Feel free to put questions, in the chat. I think Emily can help me keep an eye on those, and definitely I'm going to try to leave some time at the end for questions too. So this first slide is, the story of the three little pigs. I feel like has done a lot of damage in our perceptions of the idea of building with straw. But really, straw bale construction has its origins in the early 1900s, around the time when the straw baling machine was invented. So there were, European settlers in Nebraska. The baling machine had just been invented. The train line had not made it out to these more remote places to bring more conventional building materials. And so the settlers were like, hey, let's stack up these, bale bricks, put some plaster on them, and put a roof on. And that is what they did. So this is from 1908 in Purdom, Nebraska. But some of those structures are still standing and even occupied today. So this is Pilgrim Holiness Church in Arthur, Nebraska. It was built around 1928 and is still in use. Coincidentally, in Europe, in France, there was similar things happening at about the same time. So this is I don't speak French, so I'm not going to be able to say it right, but a house in France that was built using more of a post and beam style straw bale. So the straw bale is not bearing the load of the roof, but it's kind of it's insulation and it's a substrate for plaster. And this house is also still occupied in France. I want to go back to this slide and just say, so Strawbale construction has, evolved in different ways, which I'll get into, especially in the 1990s. But this type of construction where you stack up the bales and the roof sits on it, that is called load-bearing straw bale or Nebraska style. And, structural testing has since proved out that it's really the plaster that ends up bearing the weight of the roof, but it is a legitimate building method. The reason this post and beam, and I'm not even showing pictures really of other post and beam methods, the reason that became more popular in the 90s is just because it's hard to time it perfectly, to stack your straw bales up, not get them rained on, and put the roof on. It's very time sensitive. So that's why building a post and beam structure, getting the roof on, and then being able to install the bales at your leisure is less less of a time crunch. So in the after the, I don't know, 30s or something, there weren't so many straw bale houses built in the United States, in Nebraska, and because the train line made it out and people just kind of reverted back to more conventional building methods. But then in the 1990s, people, especially in the Southwest, Arizona, Utah, New Mexico, were kind of like, maybe we should try that again, that building with straw. And they were more motivated from an environmental standpoint of, you could see a lot of these would translate to, LEED materials and resources credits. It's a non-toxic building material. It's rapidly renewable. It's locally produced. Straw is grown, in lots of parts of the country, and you can use practically any cereal grain. It's an agricultural byproduct. I'll talk about this more later, but straw is the fibrous stalk of the plant. It does not include the seed head. So we're growing straw for the seed head for the nutritional value, but we're growing the plant for the nutritional value, but we get straw as like a byproduct. And, it can be used in animal bedding and things like that, but there's still a lot of straw around the world and even in the United States that's burned because there's not a huge market for it. It's fairly insulative. These are pretty conservative values, and there's more recent testing that is showing higher R values per inch. But it's fairly insulative. It's compostable. It doesn't create a biohazard at the end of its useful life. It's attractive to do it yourself, folks. It's something that, an average person can do. And it has this potential for affordability if it weren't for all the labor it takes to stack all these bales. On the right side here, I've just got a screenshot from the Last Straw Journal, which started in 1992, and it kind of has had some periods where it wasn't in publication, but it's been picked up again more recently. And that is like one of the ways that this technique, was spread around the world. There's straw bale structures that have been built since the 90s in lots of different countries and climates around the world. And so in addition to that magazine being one way of like spreading this methodology, because straw doesn't have a marketing department, there is no, it's kind of amazing that the technique has spread as much as it has, given that there's no profit motive really yet for people to sell straw bales, because we're selling a material. Someone is buying a material and not really a product. But there's a lot of books that were built, like here's how to do straw bale construction. And then workshops was the other main method of like sharing, this knowledge. And so the far right picture is me. I did a 6-month, it wasn't quite 6-month, build in Utah. It was 2 code in the city limits of Moab, an apprenticeship workshop, start to finish on a straw bale house. And then the middle picture is a project I worked on in New Mexico, but it was in a far rural area and wasn't permitted. And that's where a lot of straw bale innovation has happened in the last, 20, 30 years, is in rural areas where code is not enforced and people kind of have the liberty to experiment. So you might have heard of Dancing Rabbit Eco Village. It's in Northeast Missouri. There's actually several intentional communities in that area, and there's a lot of straw bale construction experimentation happening there. And it's really amazing to see. I think it's like a museum of natural building techniques, and some of them are like, wow, that's not working and kind of dangerous. And others are like, that's could be mainstream, so it's just really fascinating to visit that place. But as the method has been evolving, people have needed to demonstrate the safety of this material, and it has even gained code approval. So a lot of the questions that people ask and that code officials, of course, want to make sure are safe is like, how does straw handle fire, mold, rodents, pests? So to get into that for just a little bit here, there's been ASTM testing that's shown that a 1-inch clay plastered wall is equivalent to a 1-hour fire rating. And using cement plaster can be equivalent to a 2-hour fire rating. And just to show a little bit of a video here, this is a video put out by Croft, which is a prefabricated straw panel manufacturer in Maine, regarding some kind of informal fire testing or demonstration of their panel. So I'll turn up the volume here.
Capturing building panels, insulated with super compressed straw. And one of the most common questions we get about this material is, won't that burn? Short answer, no. But we understand the skepticism. To settle this debate, we called in a favor to our local fire chief and set a bunch of stuff on fire. We set out to compare 3 different wall assemblies by exposing each of them to 10 minutes of intense direct flame. We torched a Croft panel, a typical code minimum wall panel with fiberglass insulation and zip bar sheathing, and an OSB sheathed wall panel with closed cell spray foam. In short, we're doing a head-to-head comparison. Plant-based materials versus synthetic manufactured ones. First test, a Croft straw panel. Our panels are filled with local, organic, no-till straw because we are overachievers, but any straw will do. Straw is an inexpensive, plentiful agricultural byproduct that just happens to naturally bioaccumulate silica, which is the same stuff all other insulations add to achieve their fire resistance. Compressed in our proprietary equipment, the result is a panel so densely packed that flame just can't find a foothold. Instead, the straw simply forms its own protective layer of char within a few seconds. And further burning doesn't change much. For the record, the test we're doing here is about 5 times as harsh as the standardized test for insulation materials. After 10 minutes of this 1200-degree flame applied directly to the face of the wall, we not only hadn't got the panel to catch on fire, but the straw on the other side had only warmed by 6 degrees. When we cut the torch, our panel self-extinguishes within seconds, the only demonstrable change from all our efforts being a blackened dent in the surface of the straw, about 2 inches deep. In short, trying to burn our panel was kind of boring, which is probably the highest praise you can offer during a test like this. Next up, the code minimum panel, also known as the 20+5 wall because it has approximately R20 insulation in the stud base and a continuous R.
Sorry, I didn't mean to stop sharing there. This video goes on to test a more conventional fiberglass assembly in the same method, and then also test something that has like a rigid foam board, and which is like very explosive is maybe too strong of a word, but turns into a conflagration pretty quickly. It's an interesting video to watch, but it just does demonstrate, because that panel wasn't even plastered. So just the straw itself, there's not enough oxygen. You have to have kind of 3 things for a fire to be sustained. You have to have a spark, you have to have a flammable material, which straw is, but it's so densely packed, there's not the third element, which is oxygen. There's not enough oxygen. Yeah, I think that the fire testing is really quite amazing. And when you compare it to just conventional fiberglass, fiberglass bats in a stud cavity are kind of like little chimneys. So I think in some ways it's quite superior to conventional stud framing. Anecdotally, there have been Strawbale structures that have survived wildfires, and you can't say that every Strawbale structure would survive a wildfire, but it is quite impressive. Some of these stories of Arc and Tilt is an architecture firm in the San Francisco area that has designed a number of Strawbale structures, and they have survived wildfires. Mold is another question that people, of course, ask about. Something that we forget, though, is that straw and wood are very similar in composition. And all the concerns that we have about straw, we also should have and have had about other materials, conventional building materials like wood or blown-in cellulose insulation or whatever. And so, yeah, straw can mold and rot. So can wood. So could blown-in cellulose insulation. But only if the right conditions are present. And that's really sustained moisture above 20%. And so the amazing thing about, plant-based insulations in general is that they have great hygroscopic qualities. They can redistribute moisture throughout their cellular structure. And as long as the wall assembly is designed so that it can dry out to both sides, then you shouldn't have a problem with mold. The one place that it's most vulnerable is during construction. You want to avoid direct wetting from the top, like I was saying about the Nebraska style. And that's part of what the prefabricated method helps solve, is just speeding up the fabrication or the erection of the house on site. One other little thing is like straw has been found in dry Egyptian tombs. So like thousands of years, straw could last as long as it's kept dry. Critters, that's another thing people ask about. And as I mentioned before, straw doesn't have the seed head. So you see this mouse on the seed head of the plant. That's what critters are mostly attracted to, is the nutritional value of the seed. But because straw is different than hay, so got a little comparison here. We have hay at the top, which has the seed head included, and straw at the bottom there, which has the seed head already removed. You wouldn't want to build a hay bale house, but a straw bale house is not that attractive to vermin. If it's built airtight, it's also should be built tightly enough to avoid entry points for critters. But it also is worth remembering that typical construction methods can also house critters. So like fiberglass insulation, cellulose insulation, critters aren't necessarily attracted to eat that, but they could, nest in it if you build a house that has gaps and cracks and allows entry points for it. And the same could happen with straw bale. If there's gaps and cracks, maybe they would want to nest in it, but they're not going to want to eat the material because it doesn't have the nutrition. So after all of this testing has been going on, since the Strawbale revival began in the 1990s, a International Residential Code Appendix was passed in 2015 that codifies how you can build a load-bearing or post and beam Strawbale house. And I advocated in Columbia that the appendix be passed because Missouri doesn't have a statewide building code. Every authority having jurisdiction, has the opportunity to pass whatever sections of the code they want. So that's a little bit of a challenge, I think. There's another in St. Charles area. I forget which county maybe it's St. Charles County. I was just talking to a code official. They have not adopted the appendix. And that's it seems like, authority having jurisdictions or code commissions sort of default is not to add regulation. However, this is something, I think there's a fairly easy case for it to be made to add because it adds clarity so that if there's somebody that wants to build with straw bale, well, now there's something we can reference, a code official can reference and actually be inspecting for. And it really doesn't affect any other construction type. So, of course, this history of straw bale construction is written through my own lens, and I have became interested in straw bale construction when I was in college, and did these workshops. But then around like 2017, I became aware of like these worlds being merged, where there's people who are interested in natural materials for all sorts of environmental reasons and health reasons. And then there's the operational efficiency, like the energy nerd side of airtight construction. And those worlds were like coming together in a really exciting way. And so that really influenced my thinking when I built an accessory dwelling unit in my backyard. So this is technically called a straw cell accessory dwelling unit. And you can see it has a very conventional siding on the outside. And the reason I did that, chose this method was a few reasons. One, I was worried about the labor of installing plaster on the outside, especially like on the tall end of the building. And I was also learning about these high performance building materials. So like this black material here is Mento Plus, which is made by Proclima, which is a European manufacturer of high performance membranes and tapes that are vapor open. And so it's like, oh, we are not reliant only on plaster because plaster is an amazing air barrier and vapor open, so it can allow moisture to pass through it. But now we have other options because there's these vapor open membranes that are more vapor open than Tyvek. Tyvek doesn't have quite the perm rating that you would want. So this is just a wall section of my house. It's basically like a stick framed house, and then we put straw bales on the inside, and which is a little bit of a bummer because straw bale is capable of being load bearing, but I wanted to do this because it allowed me to just get the shell of the house up and then install the straw bales later, and I didn't have to plaster the exterior, and I still got a super insulated wall assembly. And you can see here, this is a moisture probe. This bale is at 14.2% moisture, so like totally fine. And we tested the bales before I purchased them. We tested them when they came off the trailer, like practically every single one. And then we tested them at various points during construction just to make sure that they weren't absorbing too much moisture from the wet plaster as it was installed, and running dehumidifiers, and that helped the plaster or maintain the right amount of moisture in the bales. Here's just a look at the inside. We've got a super insulated, roof assembly, ventilated roof assembly with cellulose insulation. And yeah, I'll get into some of the air tightness details, but here's just a few construction pictures. We've got the cellulose straw cell being straw bales and blown in cellulose. So the cellulose is behind that Typar netting. We're stacking up the straw bales. A lot of people were kind enough to help me on this project. There's a architectural studies student from Mizzou helping me here with another product that's like really been a game changer in the natural building world, which is also made by Proclima. It's called Contiga. It's a fuzzy tape, and it's intended to be plastered over. So at every material transition, from the window frame to the plaster, from the plaster to you can't see it behind her arm, to the window sill, from the plaster to the concrete floor, we are taping because that's where I've been in a number of straw bale houses that are actually quite leaky because straw, when it dries, it wants to shrink back. And so the cracks, there's a lot of times cracks at the top of a wall or around any dissimilar material. So this tape is like just totally a game changer, as I said. So then we plastered the walls with earthen plaster that we made on site. We stockpiled the clay from when we dug the foundations, and then we rehydrated it, mixed it up with a drywall mud mixer, and then mixed it with sand and chopped straw in a concrete mixer, and then applied it to the walls. You can see it was brown. And we did several test batches, like mixing or testing different ratios of fiber and aggregate till we got a plaster that didn't crack. But the final coat here is a kaolin clay plaster because I didn't want dark colored walls. I wanted a lighter color. So that's why it was from a ceramic supply store. And this particular, you could see there's the tape there. And then we also like mixed in some drywall mesh tape just for belt and suspenders, preventing cracking at the top. And there's also a green mesh here, which we used in some places. And then I was like, this is too much work. I don't even think we need this. So we like abandoned that mesh over big swaths of the wall. It just didn't seem necessary. So here's a finished picture of the accessory dwelling unit. And then here's a little data about how it's performing. So 2023, we moved in at the very beginning of 2023. I use it as an office and like kind of a guest house on weekends if we have visitors. But I wanted it to be net zero, and I'm proud to say it's like double positive production. I don't know what to call it. I was comfortable maxing out the size of the solar array because Columbia allowed the accessory dwelling unit to be metered together with the front house. So any extra electricity that is produced from the accessory dwelling unit goes to offset the front house's demand, and then any extra goes back into the grid. So the whole property is now like net zero electric, although we do have a gas-fired furnace in the front house. But the accessory dwelling unit is all electric, produces twice the electricity that it needs, and it got a blower door test of about just a little over 1 air change per hour, which I was hoping to meet the 0.6 to meet the passive house standard, but we just didn't quite get there. So I feel like this project, and there's many others that are demonstrating you can build a really high performance house with straw. But the next thing that has not been on my radar until the last few years is that, oh yeah, straw also sequesters carbon. So that's kind of awesome. And in addition to all the other environmental benefits and health, benefits that it has, we could be reversing climate change or carbon emissions with using plants in buildings. So this is just a little reference to this UN report that was put out in 2023, basically saying, we've been thinking about operational efficiency, this little chart here on the right, operational efficiency, that's the biggest part of the pie when it comes to buildings, and the embodied energy, or the carbon that's emitted to produce the materials, that's a smaller piece of the pie. So like, let's worry about operational carbon and reducing those emissions first. And like, yes, that makes sense. But then when you get buildings that are operationally net zero or net producers of renewable energy, then the embodied carbon, or I mean, these terms get kind of confusing. The carbon emissions from the materials, that's the only piece of the pie that's left. And that's what we really do need to care about. So this UN report is saying we need to do this. We need to have efficient buildings. And as they become more efficient, we need to be more selecting materials that are sequestering carbon instead of big emitters of carbon. So yeah, plants do this. They capture gaseous carbon from the atmosphere through photosynthesis. They sequester it in the cellular structure of their plant cells, and they sequester it in the soil. There is a Strawbale enthusiast turned researcher in Canada named Chris Magwood, who's really done amazing stuff to advance the legitimacy of Strawbale construction and other, carbon sequestering building methods. He and other folks have developed this entity called Builders for Climate Action. And this is a screenshot from a video that they have where it's basically just showing kind of these two ways that we can build. So on the bottom, this green area is like if we build with plants. Yeah, there's some emissions at the very beginning, tractors running, whatever. But then once the plant starts growing, it's sequestering carbon, sequestering carbon, sequestering carbon. Okay, yeah, now we're harvesting the straw. Okay, there's some more emissions. We're manufacturing with the straw or the hemp or whatever it is. We're shipping it. Okay, more emissions. But it is possible on net that if we build with enough plants, at the end of the useful life of that building, we will still have sequestered more carbon in the building than was emitted to produce the building. Whereas, on the other hand, the extractive kind of material cycle is like we're emitting all the way through the process. So this is just like a super exciting, way to be thinking about materials. And straw is conveniently one of the best sequesters of carbon. When you compare it, this is just comparing insulation types, but spray foam is a net emitter of carbon. Strawbale, one of the best at carbon capture. And I think part of that is just because of its low processing. Like you really don't have to do that much to it, and it's a useful building material. So Builders for Climate Action has created this BEAM tool, which I am aware of, but don't have a lot of experience using it directly, but it's, I can't remember exactly what it stands for. Building emissions, something management, I don't know. But basically you can put into this calculator, oh, here's the materials that I'm using. And it kind of spits out, well, like here, your building is net emitting this much carbon or net capturing this much carbon, whatever. So a lot of these slides have come from New Frameworks, which I'll get into. It's a Vermont company that is also making prefabricated straw panels. They have done the calculations on some of their kits, their casita or accessory dwelling unit straw panel kits. Their walls and floor panels sequestering all sorts of carbon. And that is offsetting, the carbon emissions from other materials. They're also avoiding concrete. So I feel like the more we build with plants and avoid concrete, like we're going in the right direction. But this is, mathematically demonstrating these houses are net sequesters of carbon, and they can be super operationally efficient. So this slide is also from New Frameworks, and it's just sort of talking about like business as usual. If we keep going the way we are, we're going to need more potentially coal-fired power plants, or we can, do the opposite. And if on an extreme scale, if we really shift to carbon sequestering building materials, we could retire coal-fired power plants. Like the potential is just like so exciting. So the next sort of evolution that I'm seeing is prefabricated Strawbale construction. And as I was building my accessory dwelling unit, I was like, dang, this is a lot of work. And this is not replicable. It is so labor intensive. There's not, if I had, I would I had open houses and people would come, and I think people realized like, oh, I don't want to do that work. And oh, there's no one around here I could hire really to do that work for me. So it wasn't replicable. I was feeling that and seeing that in what I was talking as I talked to other people about, site built Strawbale construction. So prefabricated, I would see online like, oh, in Europe, they're doing it. It reduces the labor. It's lowers the cost. It's able now prefabricated construction, Strawbale construction, it's something that the average contractor could install. You don't have to go to workshops. You don't have to read all the books. Like you can just install the panel according to the guide. And it is also enabling multi-story prefabricated or multi-story construction with straw, whereas I think you can do 2 stories in the code now, but we could do even more, and with commercial buildings potentially. So like the potential for other people to adopt straw as a method is exponentially increased with prefabricated methods. So as I said, it's happening around the world. It's happening in Europe like for the last 10, 15 years. This is, to my knowledge, the tallest Strawbale structure in the world. It's in France, was built in 2011. Eco Cocone is a Lithuanian company. They ship to the United States, which is kind of offsets the carbon benefit of building with straw. And but there's a few manufacturers around the United States. Croft, the one in Maine, the video that I showed, New Frameworks in Vermont. There's a kind of they're not commercially available in Michigan or Arizona and California. There's some sort of experimental things. That's my understanding. But I looked at the middle of the country and I was like, there seems to be some opportunity here. Sorry, just to go into a little bit more of some examples of prefab Strawbale structures in Europe. This is one, a gym in the Netherlands. And then this is, like a multifamily housing project also in the Netherlands. Looks fairly conventional, but like it's happening. So New Frameworks, the company in Vermont, I had been following them, and this is kind of their panel. It's a wood framed panel, and then this sort of translucent area is where the straw goes. It's compressed into the panel. The panels are, put together into wall assemblies, and they can even do floor and roof panels. The roof panels, they do not insulate with straw just because it gets quite heavy. And I'm not even sure about the floor panels might be insulated with wood fiber or blown in cellulose. The other thing about prefabricated Strawbale construction is it's like you can still do the plastering, which is like a beautiful aesthetic. And plastering is way easier built in a factory when you can apply it horizontally. But you can also combine it with these vapor smart membranes. So Intello is made by Proclima, but it's for use on the inside. It's a vapor smart permeable membrane. And here's just an example of the way that they're doing foundations to avoid concrete. They're using helical piers. And I'm sorry I don't have a better picture of like the installation of the piers, but no concrete in the foundation. Here's a little detail people are often interested about, like how do you get utilities in these panels? And one way to do it is a utility chase at the bottom, or just use furring strips all the way up and down the wall. So New Frameworks, had been building, they've been in business since 2004, and they built an average of 1 to 2 homes a year from 2004 to 2019. And this is an example of, the type of single family house that they would do. Then in 2019, or a little bit prior to that, they started switching to experimenting with prefabricated Strawbale construction. Now they're building more houses. So like when we think about meeting the twin crises of climate crisis and the housing crisis, like we're building this methodology is enabling new frameworks and, you know, other manufacturers to build more houses faster and also sequester more carbon faster. So they have, you know, just beautiful homes that they make, and they even started shipping. This is a project in Idaho. And they've even done commercial buildings. This is Soulfire Farm commercial project. It's also got pretty tall walls. You can see that they're using LVLs and kind of stacking multiple panels on top of them. And you can even build in the snow. Building in the rain is more dangerous, not so easy. Building in the snow is manageable. So here's another picture of Soulfire Farm, just so you can get a sense of like what the Vermont company is doing. There's the exterior. It's clad with a fairly, like a local wood, but you know, like it's not a plaster method on the outside. Here's some inside pictures and their truth window. Yeah, so their number of houses per year that they built after engaging in prefab construction is like, you know, exponentially increasing. And so they were in a position of thinking, well, how do we scale up? Do we rely, you know, the owner builder superhero is really not enough to scale up. Robotics, you know, like the EcoCocoon company that I mentioned, their facility is highly automated, which is amazing for producing lots of panels. But it also requires huge startup capital. So New Frameworks, you know, is like, well, straw's grown in lots of places. Maybe we should have a decentralized way of producing these panels rather than increasing the size of our facility and having the carbon emissions of shipping all the way to Idaho or whatever it is, when look, there's a lot of wheat grown in Idaho. So they are pioneering a decentralized way of sharing the knowledge of prefab straw panel production so that we can build more local, you know, grow the straw locally, assemble it into a panel locally, and also lower the barriers to entry. How can we, you know, use appropriate levels of technology that don't require $1 million in startups for robots? So they created something that is now called the Seed Collaborative. So the company that I helped start in 2024 was the first year of this Seed Collaborative. Seed Collaborative didn't have a name then. We didn't have a name. But the way it worked was we were one of two participants in this session, or this first cohort, learning New Frameworks' knowledge. So New Frameworks, I'm sorry, there should have been another slide here. There was a simpler slide and I've somehow deleted it. But New Frameworks was sharing with Building Integrity and Rare Forms, like, hey, this is how we do our panels. Here's how we market them. Here's the engineer we work with. And we paid to learn their methodology. They weren't giving away this information, but they also aren't patenting it. They're not licensing it. It's like an educational model. And so now in 2025, there are 3 new participants, and we are kind of all sharing our knowledge as we kind of work on projects independently. So in last year, the first cohort, this is Building Integrity from Columbia, me and the other co-owners, and then also the company Rare Forms in Massachusetts. They were the other first participant in this cohort. So we did, part of our training was an in-person session in Vermont, but most of it has been online via Zoom. But yeah, it was great. We got to see their jig, you know, their plastering methods, talk with them about marketing, all the things. But the vision going forward is, how can we like share our knowledge, improve efficiency, so that costs can go down, so that this can become more and more accessible to more people in the United States. And yeah, 2030, who knows where it will go. But here's a map of the participants right now. So there's New Frameworks in Vermont, Rare Forms, then 2 companies, I think, that are combining around Baltimore, Building Integrity in Columbia, and then I haven't met these folks yet. So I think A1 Design Build is in Washington and Living Craft is in Colorado. So yeah, kind of distributed around the country at this point. And yeah, that is the Seed Collaborative. So a little bit about building integrity. There were 6 co-founders. There are only 5 co-owners at this point. Nick moved to Iowa. He and his wife had a baby. So we're super happy for them, but their life took a different turn. This is the family of our first client, the Dyers. They are a family I've known for a while. They expressed some interest to me at the end of 2023 in doing like an energy efficient family cabin. And I was like, ooh, maybe you should build it out of straw bales, but maybe prefab straw bales, because I've heard of this company in Vermont that maybe wants to tell us how they do things. So they were our first client. And really, the combination of New Frameworks kind of offering this session and the Dyers being willing to be the first clients, like, was they were key in us like taking the risk to start this company and invest in New Frameworks' classes. So this is a just Revit screenshot of the house. It's pretty simple. I think it's less than 500 square feet. We learned, the employees I work with partnered a lot with Najat from New Frameworks, who shared their Revit technology or technique for like, here's how we panelize and here's how we, do all the, so we have a consistent way of generating the documents for these panels as a Seed Collaborative. And then here's a picture of the site. So it's a conventional slab. The owner of the project was the GC, and this was the first time that he had GC'd a project. So I would love to use the helical piers that New Frameworks is using, but this project wasn't the right match for that. So before the panels go on, a toe up goes up, and then we fabricated the panels in the client's barn, which was also great that they had the space for that. So this is the jig. It's the most complex piece of equipment that that we Building Integrity had to invest in. And luckily for us, one of the owners is a retired engineer, Lawrence Lyle, who Emily, I think, knows. And Larry loves tinkering, so he's always like inventing ways to do things differently. There's Larry right there. I think I have a video here. We'll see if this works. Sorry, that's so loud. Basically New Frameworks, they were, I'm trying to move to the next slide. Let's see here. New Frameworks uses like a hedge trimmer. And Larry was like, oh, I think we can do this faster with a cup grinder or something. So he created with like skateboard, what are they called, bearings or something, this way to shave the bales down. So that's the kind of innovation that then we are sharing back with the Seed Collaborative. And then the Seed Collaborative, like the people in Massachusetts, were like, hey, we adjusted the jig to make it easier to do this or that. And so like collectively, we're kind of crowdsourcing how to make this more efficient. Yeah, so here's some pictures of the panels stacked up in the barn. Of course, they have to be kept dry. And then here's a few assembly pictures. So a telehandler is a key piece. These panels are like 400 pounds, maybe. Like they could be lifted with 4 people or so on site, but like the telehandler is pretty nice. You can see here that before, this is a critical piece here where the house is a little bit vulnerable. So we've got this Henry blueskin wrapped around the top. We're really trying to protect the top and seams between panels. That we also protected the walls with plastic, if there was any bit of rain in the forecast. But here's some pictures of the house going up. The client opted to do drywall on the inside. So we wrapped the entire house with Intello, used the Tescon Vanna tape that goes with it, did a blower door test. I think it was about 1.13 air changes per hour. The entire outside is wrapped in Henry blueskin, which is a fully adhered vapor open membrane. There's a little bug screen at the bottom. But it's wrapped in a pretty conventional LP siding. You can see it's got furring strips, so we have a ventilated rain screen on the outside. And then on the inside, they did do something that's called earth house plaster, which is like a 1/32, very thin layer of plaster on top of the drywall. So yeah, straw is surprisingly ready for application at scale. what is kind of funny to me is Nebraska is kind of the home of straw bale construction in the West, shall we say. Of course, straw's been used by like indigenous people since the dawn of time, probably. But our next project that is we're hoping would go forward this summer is likely to be in Beatrice, Nebraska. So it's like prefabricated straw bale construction is now coming back to its roots in Nebraska. And I'm hoping to add on to my own house with prefabricated straw bale construction. So I will let people know about any open houses or, events that we have if you're at all interested in coming to see these structures. But yeah, I'd love to take any questions that you guys might have.
Thanks so much, Adrian. That was a great presentation. Lots of good background. Sunny, you've got your hand up and I saw your questions in the chat if you want to ask those.
Yeah, I got a lot of questions in the chat so that was coming up for me. Recently I was reading about like 3D printing homes and the cost for it. They were able to like eliminate a lot of like the labor costs for it. However, they still priced the homes at like over $300,000. So I just have a question, especially considering that a lot of homes were destroyed recently in St. Louis by the tornado and storms. Just what would be the cost difference from a conventional house to prefab straw bale home?
Yeah. So, what I have heard people at New Framework say is like they think that right now prefab straw bale is cost competitive with other high performance ways of building. So double stud or using timber HP board, continuous insulation on the outside of studs or things like that. But high performance construction, I would say, is generally it's more expensive than conventional building. Of course, there are ways to build high performance buildings that are more economical by, especially being careful about the size and orientation and complexity and windows, not doing so many windows or fancy stuff. Like, I think there's ways to build more affordable, high performance houses. But the Dyer project that we did, I think it came in around $275,000. So it's not super cheap, but it's also like the size of the house. Like if that house were to be bigger, it would have been a lesser cost per square foot. So that there's some things working against it on its cost. But I think the hope is that if we can move into a more mass production with the panels, then the cost will go down because we will just be able to see some efficiencies of scale from the production.
There's another question in the chat about the approximate duration of the construction project, the one that was I guess that's the Dyer home that you last showed.
Yeah. So the Dyer house, I think we started building panels in October. And then they were installation, I'd say the roof was on within like 10 days from the time like toe up to roof on was probably 10 days. But then the finishing out got finished at the end of March. So like about 6 months for total construction time. And you compare that to my accessory dwelling unit, which took me 2.5 years, which I also blame on the pandemic and having 2 toddlers, various things that are not all the fault of straw, but there was plenty of like labor that went into my ADU that just was not, the prefab is definitely faster.
Aaron, did you have a question? You had your hand raised.
I unraised it.
Okay. All right. Ralph, I saw you've got a question.
Yeah, for some reason I'm not finding a chat or a way to raise my hand graphically, so did it in person. Hi, Adrian. Thanks so much for your presentation. I do have a couple questions. One is, I was curious what type of roof construction you're using to tie this to the walls, and two, You mentioned in your accessory dwelling that you did that the infiltration was higher than you anticipated. So what you attribute that to, and what lessons have you learned to make it more airtight?
Yeah, let's see here. So, the first question about the roof, I could maybe pull up another picture. So the Dyer house was trusses, parallel cord trusses. They're attached to an LVL top plate that goes around the entire um, top of the walls, and that house was engineered with a company called Engineering Ventures in Vermont. They did the engineering on it because these panels don't meet the prescriptive framing criteria for the IRC. So you gotta involve an engineer, and then because the Vermont company was not licensed in Missouri, our co-owner Larry, who is a licensed engineer, provided the stamp in Missouri, just so you can understand that sequence. But your other question was about air tightness. I mean, the 1.08 air change per hour that I got for my ADU, I mean, I'm really quite proud of it. Like, I feel very good about it. It's hard to get a low um, blower door test it's harder on a smaller house. And I think that's because like you have the same kind of number of penetrations, a dryer vent, a whatever coming in the house. But you have less volume overall to like, and surface area of walls to then distribute that out over. So small houses are notoriously hard to get lower blower door tests on. And getting around 1, I feel like, is really good. The passive house standard of 0.6, like I would love to get there. And I think as I become more skilled and the people I'm working with become more skilled at building airtight houses, we can get there. But this is the first house I was the general contractor of, so I was learning a lot on the fly.
Thank you.
Yeah.
Aaron?
Yeah, I re-raised my hand because I wrote down my questions this time because I just spaced. So first I want to say that was a beautiful and clear presentation. I loved that you started with the history, and I just thought it was a very well done presentation. You're calling them prefab, but it's the first one that you showed, you built them on site in a barn. Did you bring in the hay or the straw from somewhere? Is there like a facility where you're building them to ship, or I'm just wondering about that part of it. And then like how much labor is going in per panel?
Yeah, good question. Okay, so yes, the Dyer house is, I would call it is prefab. We just didn't have, like we as a company that didn't even have an LLC when we first signed on to be part of the Seed Collaborative that didn't even have an official name. We're just like, okay, we're doing this. Oh, the Dyers can let us use their barn. Great. That was our facility. And so it was an affordable way to like get this business going. And the panels, straw is from Howard County, which is one county over. And we connected with that farmer because Nick, the co-owner or the co-founder who moved to Iowa, he built a Strawbale house in Howard County and was like, oh, I worked with this farmer. He's great. So, we worked with David Schmidt. And so the straw is quite local. And yeah, our facility was kind of informal in that it was in our client's barn. And then but the panels were then shipped from the barn like a half mile to their building site. So, but that barn, even though the owners were open to us continuing to do some fabrication there, we have since found another location that's got a little bit more room, a little bit more storage, a concrete floor. Like it's better for us at this point in our trajectory. We kind of outgrew the barn. It was barely big enough to do the Dyer's house.
So,
And I'll just, oh, go ahead.
so does that mean you now have a stockpile of made panel, or do you make them for the build? Do you fabricate them off site for a particular size that's requested by a client, or do you have like a stockpile of ready to go?
Right. Great question. So we are not fabricating any panels speculatively. We cannot afford to do that. And New Frameworks doesn't do that either. So to my knowledge, we also, at this point, because I'm an architect and can, I've the house in Nebraska that we hope will go forward is a custom home. And so then we take the custom home design and then we panelize it. And we're like, all right, we're going to have 39 inches is kind of the magic number of width because that's 2 straw bales next to each other, plus framing on the outside, you get 39 inches. So we're like, all right, we're going to do 39 panels and we make them as consistent as possible. Oh, but we're going to need a weird one here and we're going to need a weird one there. And then once engineering happens, the engineers are going to say, oh, you need extra framing in that panel. You need extra framing here. You need, oh, that header's so big, you're going to need this framing, whatever it is. So they tell us where the framing anomalies are. And so every project, has a unique like series of panels. Many projects will have 39 inch panels because that's kind of what we're aiming for, just to have consistency. But there's as long as it's a custom home, the total panels are going to be unique. The total makeup of panels are going to be unique on each project. New Frameworks has developed these casita kits. And so they've designed a thing, they got it engineered once, they've got it engineered to meet, criteria for all around the country, and then probably could work with their engineer to provide a stamp in whatever jurisdiction it's being shipped to. We as Building Integrity can build from their plans. Like we are working out a remuneration process to where if I have a client who comes to Monarch Architecture or Building Integrity and says, oh, I really love new Casita's Arbol model, I'll say, great, we can work that out for you. And and Building Integrity is going to owe money back to New Frameworks so that they can recoup the cost of like doing all the design and engineering on that. But that New Frameworks, and I too am very interested in like how can we make it's going to be faster and less expensive if we don't have to custom design every house, and we can create kits that are going to meet the needs of the clients in our area, or many of the clients.
Do you have the pricing for different, like what are they building the casitas for right now?
I think they have that information on the website. I don't have that off the top of my head, but if you go to newframeworks.com, I think it is, they have casitas all over their website, and there's different costs, like there's the panel only, then the shipping cost would vary from New Frameworks. Obviously, if Building Integrity were to fabricate a casita, then the shipping cost is going to be less. And if it's in, the Midwest. But then the finish out, like New Frameworks is only finishing out projects that are super local to Burlington, Vermont. And Building Integrity too is open to finishing out projects kind of in the mid-Missouri region, and also helping, like if somebody wants to do plaster, like our potential client in Nebraska, we're trying to do some hand holding with her and a person who does plaster, like, okay, here's how New Frameworks would do the plaster. But they're going to finish the house out on their own.
All right, we have 1 minute left until 1 o'clock. Any other last question?
I have more questions.
More questions?
Yeah, I was just wondering if you have a continuing, or you sounds like you've been to Dancing Rabbit. Do you have like, I know they've put up some prefab or offsite homes or panels, and I'm just wondering if you have a continuing relationship with them. And also, I just feedback on your presentation. I didn't understand from it that the way the press looks, it looks like you might unbale and then recompress in the frame. But those are actually just placed bales and then compressed inside that frame.
Yeah, so the bales are placed inside the jig. They're compressed. We do cut the strings at the end. I'm not even sure why, but like, and then depending on the height of the panel, like we might need a portion of a bale to finish out. Like the bale length doesn't always correspond to like the height of it doesn't always fit as a perfect module. But like so I don't know if that makes it clear. Sorry, my daughter has joined me here. Yes, do you want to say hi, Maggie?
Hi.
As far as Dancing Rabbit, I have talked with some people there. They were very interested in kind of learning more. I'm not sure how much offsite or prefab stuff they have been doing, there might be some connection there. But when you said continuing, I thought of continuing education unit, which made me think I do want to tell people we are developing an AIA CEU, hopefully that we can be presenting this summer, because I would love to be. So if you know of people who would want to hear this information and get a CEU, please contact me. I would love to do Zooms or in-person trainings, you know, in St. Louis or whatever.
Awesome. Well, Adrian, thank you so much for this presentation. That's fantastic, to learn a little bit more about what you're working on and just the larger kind of network of folks that are working on scaling up Strawbale. I do just have a couple quick announcements for folks. Next week, we are canceling our emerging professional happy hour, which is normally the first Thursday, and instead inviting everyone to attend a tornado relief fundraiser on the 3rd. Tuesday the 3rd, it's from 4 to 6 at Built Interiors. David Charles is doing a lot of work to coordinate this, but we're kind of co-hosting with ULI and Landmarks and what's the other group that's part of this company, Design Surfaces. So you can bring things to donate, the needed donations, and things will be going to For the Bill, and then there's several raffles, and all of the proceeds will be going to For the Bill as well. And then the following week on June 10th is our summer member social. That's from 5 to 7 p.m. at Brentwood Pavilion. We'd love to see you there. And in between there, on Saturday the 7th is the Green Living Festival at Missouri Botanical Garden. So encourage everyone to check that out. It's from 10 to 5 in the primarily in the Bayer Visitor Center, but you'll access that through the main through the Visitor Center, through the Bayer Event Center, right, which is adjacent to the Visitor Center. So thanks everybody for joining, and thanks Adrian for a great presentation, and have a great Friday.
Thank you so much, everybody.
Bye,
Thanks
y'all.
so
much, Adrian.
Thank you.